Hess's Law, Lecture 2, commencing. If you will recall, we just finished up with problem 5.61. When we crossed these things out and you took these two guys, you added this, just a point on the significant figures. In essence, these are all additive properties, so you're adding and subtracting. Sometimes you'll be, in this next problem, adding and subtracting more than one, but it's still, let's sort of follow that places to the right kind of thing with the significant figures. So that's where we get this negative 1300, and you add these two and go one place to the right. Okay, so we're ready to move on to 5.62. You can see what we want is hydrogen reacting with ozone to give 3 water molecules. That's a really hard reaction to figure out what the energy is. So we use in 5.62, this is a black problem, so the answer will not be in the back. We are given a relatively easy reaction to do, which is hydrogen and oxygen. Boom. Can easily, just a little spark in there would get those guys going and then turn into water. This is very easy to register this. And conversion of oxygen to ozone, also relatively easy reaction to study. But this one, you've probably never seen that reaction before. This is both of these guys are very, very common reactions. So this is a really good example of what we need to do. So you can see here that it looks like we got the hydrogen in the right place, because there's only one place where it is, and it's on the left side. And it looks like we got the water in the right place. However, you don't have the right number of water molecules. So we're going to put that one on hold and see what happens when we do this one right here, which we can see we got the ozone on the right side, but we need it on the left side. So that's why I flipped this guy right here. Okay, so I put the 2 ozone molecules over there on the left, and then I had 3 O2 molecules. Well, when you do that and you flip it, of course, that's going to flip the sign, and then this one becomes needless. So let me crumple that up. I'll do a little sound effect for crumpling the paper. All right, and then we have this sort of thing going on. Well, I know I need these oxygens to cancel out because you don't see any O2 in here. So what I'm going to do is I'm going to see that I need 3 oxygens and 3 oxygens. So I'm going to triple this guy. Everything, you got to do the whole shooting match. Times 3, times 3, times 3. That gives you this reaction. And just for clarity, let's write that in there. 3 times that negative. And again, think of that as adding that up 3 times. So we'll go one place to the right. Some of you might be tempted to use 4 sig figs, but these values are accurate to the 10th, and we are in essence adding that 3 times. So we'll crumple up that one, and then we now have this reaction combined with that one. Well, you'll see that the 3 O2s cancel out, but you'll notice there's just a little bit of a problem here, because if we are circling, the 2 things on the left are 6H2, a little bit too much, and 2O3, a little bit too much, and too much water. So what I'm going to do is I'm going to write that reaction. So just to clarify there, the things that are circled in orange there are going to be this reaction. Well, I think you can probably figure out what we're going to do in this example. You're going to take the 6H2, 2O3, giving you 6 water molecules, and you're going to divide everything by 2, and guess what you'll have? So these are going to be additive. The negative 450 plus the negative 284 are going to give you negative 1735.4, and then you're going to have to divide that by 2. Crumple that up. We don't need the 626 anymore. We need the 313, which is this one, divided by 2. And again, keep with that 1 sig fig to the right. I think that's just the best way to do these problems, is just do your sig figs that way. Okay? So now you're able to figure out something that is a really, really hard reaction to do, and you were able to say it's an exothermic reaction with that delta H value. All right? So I think you can figure out the pattern right now. We're going to go to 5.63 and take some time to write this. This is the given, and this is our unknown right here. So go ahead and hit the pause and get all of those written in. This one we're using almost every line, and I think the last problem you'll be using all of the lines as well on 5.63 or 5.64, which is going to be one you get to do on your own. So hopefully you got all this stuff written in now. If not, hit that pause and get it so we can talk about these relatively quickly. You can see this one, you kind of want to look for the ones where there's only one place where this is, and there's only one HF, and it's right there. And at this point, you can actually say, well, I'm going to have to double this, because I know I need 4 HF. So that one you didn't have to kind of play a move ahead like in chess. You just go, yeah, I need 4 HFs. It's right down there. So you're going to double that, which means you'll double that and crumple away. And then you will end up with 2 times 537. Now notice that has no places to the right. We're going to assume this 0 is significant, by the way. And we'll crunch the numbers that way. Okay, so this particular one was not as accurate, so there's no places to the right, so that's why we said 1074 kilojoules, 0 places to the right. So now we got this one. What are we going to do with this guy right here? We got the CF4. That's a good one to use because there's only one place where it is. Okay, and we've got the F2s also, but they're in a couple of different places, so that's not as useful. So you definitely can see that the CF4 has to be on the right side, and you guessed it, we have to double it again. So instead of 121, you're going to go 242. Get rid of that guy, double it, and then you end up with 1360 kilojoules. Okay, and I can't remember. We'll find out when we get the final answer if we assume that was significant or not. So here is this last one. What are we going to have to do with this guy? We can see I got to have this on the left side, the C2H4, which is ethene. So we're going to have to flip that guy and then flip the sign. Crumple, crumple, crumple. And then you'll see that the hydrogens cancel out. And when we start looking at the products, we can see that when I circle these guys, and then the carbons also cancel out. So you don't want any carbons in here anyway. So you had one on the left, one on the right. So do that maybe with a nice colored pen. And you can see with the fluorines, I'm going to group those together. And that's where the 4 plus 2 is going to give you 6. These guys right here are going to be 2 separate products, which is exactly what you need. And you need one of these guys. So now I can take that number plus that number plus that number, and I can get 2490. It looks like I made the assumption that doesn't have a bar over it, so let's assume that it's accurate to the tens position. So that's why I put 2490. just because of significant figure rules. And I don't want you to get too bent out of shape about that, but we're just being purist. There's nothing to indicate that 0 is being significant, so I guess we just can't make that assumption on this problem. Okay? All right. So, just 1 second. Sorry about that. I just had a slight interruption there. So, I wouldn't really get too bent out of shape about those sig fig things. We're just being purist, which is always good. So anyway, that is the correct answer for that problem. Okay, so now, guess what? It's time for you to do one of these on your own, and this is going to be homework for you. If you look at 5.64, they're all one place to the right, and it's going to be one that has 3 reactions, so you'll have to figure that out. So this is the last page. It's a black problem, so the answer is not posted. So you will turn this in when you take your test, which is either Tuesday or Thursday of next week. And make sure that you do this problem and kind of follow the format, especially from the previous one. And this is going to be all filled up because this is a good one. It's the hardest one, so I thought I would save that for you guys to do, and hopefully you have the concepts down, and you can get the right answer. But you can use each other to figure out the right answer, but you cannot use me because I don't know. There is one other person who knows the answer, but he is choosing to remain silent. Correct? Yes, see? He's nodding, which means he's going to remain silent on the issue. Right, Dwight? All right? Yeah, I'll talk to you after we sign off. Okay. All right. So, take care. This is not due until you take your test next week. On Monday, we're going to do another way to figure out enthalpy, which involves some calculations. So if you think about it, we now know how to do calorimetry, which we'll get into with the lab, and you can use Hess's law to figure out enthalpy change. And then on Monday we're going to talk about the third and final way of doing that, and then we'll test a book test on Tuesday if you're in school, or Thursday for the rest of you. Okay? Kind of the same way we did this test. And then we only have 2 units, or no, we got 7, 8, and 9. We got 3 units left after that. Okay? All right. So take care. Have yourself a great weekend.